Desktop hardware. Desktops continue to be an essential tool in both professional and personal settings. Their reliability, power, and versatility make them the preferred choice for various tasks such as content creation, data analysis, gaming, and more. Plus, unlike some mobile devices, individuals can customize and upgrade them however they want. Welcome to the Desktop Hardware module. In this module, you'll explore the many components of desktop computers, including how to install and troubleshoot them. First, you'll learn about desktop hardware components, such as the system board and power supply unit, PSU. Then, you'll learn about how to install and configure desktop hardware. Finally, you'll learn how to troubleshoot and resolve common desktop hardware problems. After completing this module, you should be able to identify the function and select the location of the main components of a desktop computer. Explain the processes to install a system board, central processing unit, CPU, random access memory, RAM, and peripheral for a desktop computer. Choose a desktop storage solution based on user needs. Determine a desktop hardware component to review and perform a maintenance task based on symptoms. Imagine a busy city that's full of life. People, cars, roads, and buildings all play a part in keeping the city running smoothly. In the same way, the components of a desktop computer work together as a system to perform tasks and process data. There are components to direct traffic, allow quick access to data, store information, and supply power. In this lesson, you'll learn about the key components of a desktop computer, including the system board, central processing unit, CPU, random access memory, RAM, and storage. You'll discover how they work together to process information and store data, and how each component can impact the overall performance of a computer. Desktop hardware. Page 1 of 2. Video transcript. Desktop hardware. Meet Lisa, an enthusiastic graphic designer, ready to embark on her latest creative project. Lisa built a desktop computer specifically for her needs. Let's review all of her desktop hardware and how it's optimized to help her complete projects. Desktop hardware refers to the physical components that make up a computer system and enable it to function. Let's take a deeper look inside the desktop's tower, or case as it's commonly called. This is where all the components of Lisa's computer reside. First up, the central processing unit, or CPU, is the brain of the computer. It handles calculations and executing instructions. Lisa has many clients, and she needs to be able to get work done quickly and efficiently. The CPU has key features, such as clock speed and core count, that determine its processing power. Computers with a powerful CPU complete tasks swiftly, ensuring efficiency in Lisa's creative endeavors. Now, let's explore the memory modules, specifically long-term storage. Storage devices, such as hard disk drives, or HDDs, and solid-state drives, or SSDs, are the long-term memory of the computer. They store all files and programs. These storage devices also provide access to data, ensuring that Lisa can retrieve her extensive collection of design files without delay. For Lisa to access her files, she relies on random access memory, or RAM. RAM is the computer's short-term memory. It stores data that the CPU needs to access quickly. When Lisa opens a file, data from long-term storage is loaded into RAM for faster access. As Lisa interacts with that file, changes she makes and data from the software may be temporarily stored in RAM for smooth operations and more responsiveness. Lisa often uses multiple applications simultaneously. Having enough RAM enables smooth multitasking. So Lisa can work on multiple graphically demanding applications without any slowdowns. When it comes to visually stunning designs and creating complex, high-resolution animation, Lisa relies on a graphics processing unit, or GPU. A dedicated GPU handles graphics-intensive tasks, ensuring vibrant visuals and smooth rendering. This makes Lisa's designs come to life. The system board ties all the hardware components together. It allows the components to work together and communicate with each other. Page 2 of 2. This system board provides connectivity and power to ensure seamless communication between the CPU, RAM, storage, and other components. Alongside the core components, peripherals like keyboards, mice, and monitors allow Lisa to interact with the computer, giving her creativity the tools to flourish. Behind every computer's reliable performance lies the power supply unit, or PSU. The PSU ensures a steady and adequate supply of power to all the hardware components, preventing any disruptions during Lisa's creative endeavors by converting AC power to DC power. By understanding desktop hardware, Lisa built and optimized her system to maximize performance for her graphic design projects. It's important to remember that desktop hardware components play a vital role. They all work together to be quick and efficient for smooth operations. What do you think? Employability skills. Growth mindset. How does learning about desktop hardware parts like the CPU, long-term storage, RAM, and system board change the way you think about desktop computers? In what ways might this knowledge help you in daily life or future jobs? Evaluate your thinking. Does your answer account for the following? The individual components that make up a desktop work together as a system. This system allows computers to complete tasks with ease. This knowledge can help you with tasks such as purchasing a new desktop, understanding the performance of a current desktop, or troubleshooting common desktop issues. Understanding the components of a desktop is critical for careers in IT support and can be useful for careers in other IT-related industries as well. The system board. The system board, also known as a motherboard, in a desktop computer, is the main circuit board inside a desktop computer. It's the nervous system of the computer. It connects and communicates with all the other components in the computer, including the CPU, memory, storage drives, optical drives, video cards, and sound cards. The system board also provides power and data connections for various peripherals, such as keyboards, mice, printers, and monitors. The system board in a desktop computer is usually a large rectangular board that fits inside the computer case. It has different types of sockets, slots, and connectors for attaching various devices. It has headers, which are small sets of pins that enable the connection of additional cables and components, such as cooling devices. The system board also has a chipset. The chipset coordinates the data flow between the CPU, RAM, storage devices, and other peripherals. The chipset provides interfaces and protocols for components to communicate effectively with each other and the CPU. The system board also holds read-only memory, ROM, chips. ROM is a type of non-volatile memory, meaning that the data is stored even when the computer is powered off. ROM chips contain firmware or data that a user cannot alter. This includes the basic input/output system, BIOS. The BIOS provides instructions the computer needs to start up, initialize the other components, and load the operating system. IT support technicians need to be able to identify, install, troubleshoot, and replace the system board in a desktop computer. As an IT support technician, you will need to know how to update the BIOS and configure the system settings. The system board is an essential part of any desktop computer, and understanding its role and functions will help you provide better IT support. Inside the desktop computer, the system board contains a lot of powerful technology, but desktop users can only access that technology when other components are added to the system board. Select each marker, plus, on the following diagram to learn more about the components the system board supports. The main system board houses the CPU, RAM slots, expansion slots, and other essential components. Random access memory, RAM, provides temporary storage for data that the CPU needs to access quickly. The Central Processing Unit, CPU, is the main processor of the computer and is responsible for executing instructions and performing calculations. Input/output ports enable users to connect devices to a computer using a cable. Users can connect devices such as a printer, a mouse, and a keyboard with a cable. Some users in specific industries, like the medical or retail industries, use ports to connect specialized equipment such as a digital stethoscope or receipt printer. Storage includes hard disk drives, HDDs, and solid-state drives, SSDs, that store data for long-term use. The chipset coordinates the data flow between the CPU, RAM, storage devices, and other peripherals. It provides interfaces and protocols for components to communicate effectively with each other and the CPU. A network interface card, NIC, is a type of expansion card that connects the computer to a network. The NIC enables a computer to send and receive data packets over a network by breaking data into packets, adding media access control addresses to packets, and handling error detection and correction. A sound card is a type of expansion card that handles audio processing, providing better sound output and input options, especially for activities such as music production and gaming. The sound card converts digital audio to analog signals that can be sent to speakers or headphones. A graphics card is a type of expansion card that handles graphics processing. Graphics cards have a special type of microprocessor called a graphics processing unit, GPU. Graphics cards render images, videos, animations, and other visual elements by converting raw data into visible content. They also perform complex calculations related to lighting, shading, and texture to create realistic 3D graphics. Expansion slots are spaces for additional cards that enhance the computer's capabilities and connectivity. Some examples of expansion cards include graphics cards, network interface cards, and sound cards. A mathematician named Alan Turing was one of the first to work with the idea of a digital computer in the 1930s. Turing discovered that computers could perform computations with just two digits, 0 and 1. By themselves, they can represent two states, such as on and off, open and closed, or yes and no. Think of the bit, or Turing's idea of two states, as a single object that can be in one of two states at any given time. A bit is a binary unit. It can either be 1, or on or open, or it can be 0, or off or closed. At any given time, it must be in at least one state, and it cannot be in both states. Representing something as open or closed or on or off is helpful but limited. However, if you combine bits, you can represent more information. For example, if you have 2 bits, you can now represent 4 different states: on, 1 to 1, on off, 1 to 0, off on, 0 to 1, and off, 0 to 0. Bits are exponential. The more bits you put together, the more states you can represent. This combination of bits is what gives digital computers their power. This is how they process information. And it all starts with the simple bit. The power of the bit. Imagine that you have a room with 8 distinct sections, each controlled by its own light switch. You can control the lighting of each section by turning its corresponding switch on or off. If all switches are off, 000000000 in binary, the entire room is dark. If the first switch is on and the rest are off, 000000001, only the first section of the room is lit. If the first 2 switches are on, 000000011, the first 2 sections are lit, and so on. Now, let's look at the power of binary by understanding how you can create varying patterns of illumination by using different combinations of switches. To light up half the room, turn on the first 4 switches, 000001111. To create a pattern of alternating light and dark sections, use a combination like 01010101. The precision with which you can control the room's lighting shows the power of the binary system. Just as you can control the lighting in the room with 8 switches, a computer can use bits to represent a vast array of information, perform complex calculations, and execute a multitude of tasks. Every additional switch doubles the number of possible lighting combinations in the room. Similarly, in the binary system, each additional digit, bit, doubles the amount of information that can be represented. The simple on/off principle of binary, like the flipping of light switches, is the foundational concept that powers the complex world of computers. The CPU and the binary system. Computer systems are binary systems. Specifically, central processing units, CPUs, process binary information. Computer programs contain combinations of zeros and ones that tell the CPU what to do. Think of the CPU as the master control room filled with light switches that control the lighting in various rooms, data and instructions. The CPU's job is to follow specific instructions to toggle these switches on or off in the right order, creating different patterns of light, performing computations and operations. Here's a breakdown of how this process works. Numbered divider 1. Receiving instructions. Imagine that you have a set of instructions telling you which switches to flip and in what order. In a CPU, these instructions come from a program running on your computer. Numbered divider 2. Decoding the instructions. Next, you need to understand what the instructions mean. If an instruction says, light up the first 3 sections, the CPU must decode this into a specific series of switch flips, that is, turning on the first 3 switches. Numbered divider 3. Executing the instructions. Once you've figured out what the instructions mean, you flip the switches. The CPU does this by sending electrical signals to turn the corresponding binary values, zeros and ones, on or off. Numbered divider 4. Storing results. After executing the instructions, the resulting pattern of light might need to be stored for later use. In a CPU, this would be storing the calculated data in memory, such as RAM, for quick access later. Numbered divider 5. Repeating the process, the CPU continues to receive, decode, execute, and store instructions at an incredibly rapid pace, allowing your computer to perform complex tasks such as displaying a web page or playing a video. The power of the CPU, much like the control room of light switches in the example, lies in its ability to follow complex instructions by manipulating simple binary values, light switches, at an extraordinary speed. It's this binary system and the CPU's precise control over it that enable the complex functions of modern computers, all using simple on and off positions. The central processing unit is the brain of the computer, handling most of the data processing. It crunches millions of ones and zeros every second. When you type on or speak to a modern computer, the CPU takes that information and processes it to give you the result you are expecting. The CPU chip is a small circuit board that consists of transistors, which are semiconductors of electrical signals. These transistors exist in processing cores inside the CPU. Some CPUs also have integrated graphic processors. As it runs, the CPU generates heat and often has its own fan for cooling. As an IT support technician, you might find yourself replacing a CPU to provide the user the ability to process data faster or if heat has caused the CPU to fail. RAM, a desktop's short-term memory. Computers need to store information that they process for you. Random access memory, RAM, is like a workspace that holds things you currently need or are currently working on. For example, if you currently need a document, you can go to a file cabinet, grab the document, and place it on your workspace. When you're done using the document, you put it back in the file cabinet, your long-term storage. Similarly, RAM holds information temporarily while the CPU, or the GPU, uses it. For example, if you need to edit a document using word processing software, the contents of the document are temporarily held in the computer's RAM. As you type, make changes, or format the document, the system stores the changes in RAM to provide a fast and responsive editing experience. When you save your document to your file system, the document and your changes move into long-term storage. The term random access refers to the way a computer's processor can quickly retrieve data from the computer's RAM without needing to follow a specific order. Imagine RAM as a collection of storage slots, and each slot can hold a piece of data. The processor can access any of these slots directly, regardless of their location in memory. This ability to quickly fetch data from any slot is why it's called random access. RAM is located on a board or chip inside the computer. In general, depending on what the CPU can handle, the more RAM a computer has, the faster users will see results on their computer. When the computer is off, RAM is erased. As an IT support technician, you might find that you need to install more RAM if a user is upgrading to a new operating system, or uses many resource-intensive applications. ROM, a desktop settings storage. Computers also require a way to store essential information that doesn't change, like the instructions for starting up the system. Read-only memory, ROM, is like the blueprint of a building. ROM holds the essential instructions that the computer needs every time it starts up, like the way a blueprint provides a guide for constructing a building. When you turn on your computer, it goes through a specific sequence of steps known as the boot process. Booting is the process by which a computer starts up, initializes hardware components, and launches the operating system, OS. The ROM stores this process and executes it every time you power on the computer. Unlike RAM, which can be changed and accessed randomly, ROM is read-only, meaning the data stored in it cannot be modified, or can only be modified with great difficulty. Imagine a blueprint of the Taj Mahal that is stored in a museum. It's there for reference, but no one is able to make changes to it, and everyone refers to the same copy. Since ROM contains vital data for the computer's operation, it remains intact even when a user turns off the computer, like a building's blueprint, which is always there, even when the building is not in use. Although you can add more RAM to a computer to increase its speed and capability, ROM is usually a fixed amount, serving a specific and unchanging role in the system's operation. It ensures that the essential functions are always available, providing stability and consistency to the computer's operation. As an IT support technician, you might find yourself diagnosing firmware-related problems such as a boot failure, where a computer is unable to start up and load the operating system. You might also have to guide users through BIOS settings and ensure proper firmware updates are performed to restore system functionality and stability. Storage drives, a desktop's long-term storage. The computer must also store permanent data. When data requires storage, even without computer power, the storage drive acts as a file cabinet, saving information for future use. Storage drives store a desktop's operating system, applications, and saved files. Computers use two types of storage drives for long-term storage. A hard disk drive, HDD, contains spinning magnetic disks, known as a platter, that holds data. This platter is divided into sectors. An arm moves across the platter to read and write data to the sectors. A solid-state drive, SSD, has no moving parts. It stores data on a computer chip the way RAM is stored, but the data stored on SSDs is permanent. It remains stored when you turn off the power. Select each tab to learn more about these disk drive differences. Speed. HDDs tend to be slower in data retrieval but offer more storage space for less cost, making them suitable for servers or workstations that need large amounts of storage. SSDs, on the other hand, offer faster speeds, lower power consumption, and are less likely to fail due to physical shock. This makes them ideal for high-performance systems, including those that host critical applications. The type of storage can significantly impact the efficiency and speed of common business tasks. For example, an IT support technician might need to deploy an operating system to several workstations, retrieve the backup of a large database, or troubleshoot an application with high input/output operations per second. So, Understanding the type of storage a desktop has becomes essential for optimizing task execution and ensuring smooth operations. Energy efficiency. SSDs consume less power than HDDs because they don't need to spin disks or move mechanical parts. This can lead to reduced energy consumption in desktops and data centers. Knowing the energy efficiency difference can influence the choice of storage, depending on energy considerations. Durability. SSDs are more durable than HDDs due to their lack of moving parts. HDDs, with their mechanical components such as spinning platters, are more vulnerable to physical shocks, vibrations, temperature fluctuations, and wear over time. In contrast, SSDs are highly resistant to shock, vibration, and extreme temperatures, making them more durable and dependable. SSD's absence of mechanical wear, coupled with wear leveling algorithms, contributes to their longer lifespan and enhanced performance, particularly in environments where resilience to physical stresses is crucial. Understanding the differences between HDDs and SSDs can help IT support technicians provide effective troubleshooting, ensure hardware compatibility when recommending storage solutions, and facilitate performance optimization. Considerations for storing data on desktops. As an IT support technician, you might assist in implementing storage solutions for disaster recovery. Or you might be asked to optimize the performance of a desktop for an employee who needs quick access to large amounts of data. There are a few considerations to ensure that data is stored securely and efficiently on desktops. Backup. Data loss in both types of storage drives can have severe consequences, like losing critical business data or causing system downtime. Therefore, a sound backup strategy and understanding of array of independent disks, RAID, configurations, data redundancy, and disaster recovery concepts is paramount for an IT technician. RAID setups offer enhanced data redundancy or performance by distributing data across multiple drives. By comprehending the various RAID levels, IT support technicians can design storage architectures that ensure both data protection and optimal performance. There are 5 common RAID levels that offer differences in performance, redundancy, and storage efficiency. This allows IT support technicians to select the one that best fits their specific needs and objectives. Here are some key terms to be familiar with. Striping is a storage method that splits files and data into a set of smaller, manageable pieces called blocks, and writes each block to a separate disk drive. Parity is a technique used to provide redundancy in storage systems. To do this, the system writes a calculation that can reconstruct the data if one of the drives fails. Fault tolerance is the ability of a system to continue operating without interruption, even when one or more of its components fail. Select each card to learn more about the 5 RAID levels. RAID 0, Striping. RAID 0 uses striping to distribute data across multiple disks, which increases data processing speeds. This level offers no redundancy, or fault tolerance, meaning that a single disk failure can result in data loss. RAID 0 offers increased performance appropriate for non-critical data where speed is prioritized. RAID 1, Mirroring. RAID 1 duplicates data instead of splitting it into blocks and writes it to 2 or more drives. RAID 1 is ideal for critical data that requires a high fault tolerance. RAID 5, Striping with Parity. RAID 5 uses both striping and parity to split data into separate drives, ensuring high fault tolerance. RAID 5 allows for the failure of one drive without losing any data and is ideal in business environments because it offers a balance of speed and redundancy. RAID 6, Striping with Double Parity. RAID 6 is similar to RAID 5 but creates 2 sets of parity information. RAID 6 allows for the failure of 2 drives without data loss and is suitable for mission-critical applications where extra redundancy is vital. RAID 10, 1+0, Stripe of Mirrors. RAID 10 combines RAID 1 and RAID 0 by mirroring and then striping the mirrored data. RAID 10 is ideal for environments requiring both high data performance and fault tolerance, such as databases. You have explored the 2 types of storage drives, their differences, and ways that IT support technicians can back up data with different RAID levels. Now, check out some new storage drive technologies. New technologies. Technologies are constantly evolving in the storage world. Advances like non-volatile memory express, NVMe, SSDs connect directly to the system board, delivering speeds far faster than traditional SSDs. At the same time, the landscape of how companies store and access data is shifting, with cloud storage becoming increasingly common. Whether it's safeguarding against data loss through robust backup strategies or staying abreast of the latest technologies, such as NVMe SSDs and the growing trend of cloud storage, the landscape of data storage is both complex and dynamic. So far, you've learned about the basic parts of the desktop computer that make the computer capable of processing and storage. There are other components that desktop computers need to run properly. When troubleshooting desktop computers, the issue you're investigating might be related to these other components, even though that might not be obvious at first. It's important to think of a desktop computer as a system where each part is interrelated. Select each section to learn about other components that desktop computers rely on to work properly and areas to think about when troubleshooting. Power supplies. The power supply unit, PSU, provides power to the internal components of a desktop. The PSU is responsible for converting alternating current, AC, power from a wall outlet to low voltage direct current, DC, power that the desktop's components can use. PSU ratings, often in watts, are a key indicator of its capacity to supply power. High-performance components, like gaming GPUs, demand higher wattage. The power supply unit also offers protection against power surges and voltage instability. When diagnosing system instability or failure to boot, the PSU is a critical point of consideration for IT support technicians. Technicians always check the PSU's specifications to ensure it matches the power requirements of the desktop they're evaluating. The total power consumption of the individual components in a desktop collectively determines the necessary wattage of the PSU. Cooling systems. Heat is a byproduct of electronic devices. In a desktop PC, the CPU, GPU, and PSU generate the most heat, especially under heavy use. Without effective cooling, these components can overheat, leading to a reduction in performance at a certain temperature. Common issues related to overheating hardware components include thermal throttling, system instability, or hardware failure. Cooling systems typically include heat sinks, thermal paste, case fans, CPU fans, GPU coolers, and, sometimes, liquid cooling solutions. Understanding the cooling solutions used in a system can help IT support technicians diagnose issues related to system overheating. Additionally, maintaining and ensuring the proper functioning of these cooling solutions is an important part of regular system maintenance. Cables. In a desktop computer, different types of cables serve distinct purposes. For example, power cables from the PSU deliver power to desktop components. Display cables are also essential in establishing a connection between the GPU and the monitor, affecting the quality and resolution of the display. Data cables transfer data between the computer's system board and storage drives like HDDs and SSDs. IT support often involves diagnosing issues with these cables, such as ensuring correct connections and proper functionality. Issues can often lead to component malfunctions or data transfer problems. Understanding how these cables work and their roles in a system's function is a fundamental aspect of IT support. Next, you'll use what you just learned to identify desktop computer components. Summary and looking ahead. In this lesson, you learned about the main hardware components of a desktop computer and how they function. You learned that computers process information using a binary system, how the CPU provides processing, how a RAM provides short-term memory, how a ROM provides storage for settings, and how various storage devices store information. You also learned the basic functions of other essential components, including the power supply unit, cooling systems, and cables. The next lesson covers how to install and configure components of a desktop computer. About this lesson, install and configure desktops. Have you ever wondered what goes into building a computer from scratch? Or how to upgrade an existing desktop with new components? In this lesson, you will learn the skills to do just that. You'll learn about the different components that make up a desktop computer, choosing the right parts based on needs, and assembling and installing them correctly. The Central Processing Unit, CPU, is the brain of the computer and handles data processing in the computer. IT support technicians might need to install a new CPU if they are building a new computer or if the CPU becomes damaged or begins failing. Components and tools. To begin the process of installing a CPU into the system board, you'll need to first gather the hardware that you'll need. Using the right tools and compatible components ensures a successful installation. Check out the following table to learn about the hardware you need to install a CPU. Here is the extracted text from the image converted into full sentences, organized by each hardware component and tool. Hardware components and tools. 1. Compatible CPU. CPU's process instructions. Choose a CPU that can physically fit into and is compatible with the specific system board you are using. Compatibility is determined by the CPU socket on the system board, the chipset of the system board, and sometimes the BIOS version. 2. Compatible system board. The system board connects components, including the CPU, RAM, and hard drives. A compatible system board accommodates the specific CPU you have chosen. It must have the right socket type for the CPU and support the power requirements and feature set of the CPU. 3. Thermal paste. Thermal paste, also known as thermal compound or thermal grease, improves the thermal conductivity between the surfaces of the CPU and the cooler. It helps to eliminate air gaps or spaces, which are poor conductors of heat, from the interface area to maximize heat transfer and dissipation. 4. CPU cooler. The CPU cooler, which consists of a heatsink and fan, or, in some high-end cases, a liquid cooling system, regulates the CPU's temperature. It works by drawing heat away from the CPU and dissipating it, preventing the CPU from overheating. 5. Screwdriver. You use the screwdriver to secure the system board to the computer case and to secure other components to the system board or case. You can use a Phillips screwdriver for a typical computer assembly, but having a variety of both flat and Phillips screwdriver sizes can help with hard-to-reach places. 6. Anti-static wrist strap, optional. An anti-static wrist strap prevents electrostatic discharge, ESD, which can damage sensitive electronics. It works by grounding you to the machine, equalizing the electrical potential between you and the CPU/system board to prevent an ESD. Although not everyone uses these, they can be helpful when working in a carpeted area or in a dry environment where static electricity can build up more easily. Installing a CPU. With the correct tools and parts organized, you're ready to install the CPU onto the system board. Like any complex system, the installation steps involved might differ depending on the model and brand. But the following steps are, in general, the ones you would take to install a CPU onto a system board of a desktop computer. Prepare the system board. Before you start installing the CPU, you need to prepare the system board. Lay it down on a clean, flat surface where you can work comfortably. Check the CPU socket. Every system board has a specific type of socket that can fit a particular type of CPU. Ensure that your CPU is compatible with the system board socket. This will usually be labeled clearly on the socket and CPU box. Lift the CPU socket retention arm. Look for a small lever or arm on the side of the CPU socket. This is the retention arm. Lift this arm to prepare the socket for the CPU. Align the CPU and socket. On the underside of the CPU, you'll see several small gold pins. On the socket, you'll find corresponding holes. Align the pins with the holes. Also, look for a small arrow or triangle on one corner of the CPU and the socket. Align these to ensure the correct orientation of the CPU. Install the CPU. Gently place the CPU into the socket. Don't apply pressure. It is very easy to bend or break the pins on the underside of the CPU. The CPU should fall into place with ease. If it doesn't, double-check the alignment. When the CPU is in place, lower the retention arm to lock the CPU in the socket. Apply thermal paste. If your CPU cooler doesn't come with pre-applied thermal paste, apply a small, pea-sized amount of thermal paste onto the center of the CPU. This paste helps provide better heat transfer from the CPU to the cooler. Install the CPU cooler. Align the cooler over the CPU. Make sure the cooler's fan is facing the correct way for optimal airflow. Use the screws or clips to secure it to the system board. Plug the cooler's power cable into the correct header on the system board. Remember to handle all components with care and take your time with the installation process. Even though you're dealing with a complex piece of machinery, don't feel intimidated. With careful attention and patience, you can successfully install a CPU. CPU configuration. When all the components of the computer are in place, you can configure the CPU. You'll have to return to this step after you have installed the rest of the desktop components. Once you have installed the desktop components, power up the computer. Find either the basic input/output system, BIOS, or the Unified Extensible Firmware Interface, UEFI. They should automatically display. Here, you verify whether the system correctly identified the CPU and adjust any settings as needed. A system board is the main printed circuit board in any computing device. It's the heart of a computer, housing the central processing unit, CPU, memory and providing connectors for peripheral devices. Upgrading or replacing a system board, also called a motherboard, can breathe new life into an older computer or be the foundation of a powerful new system. However, handling and installing a system board requires both precision and knowledge, as even minor mistakes can have substantial consequences. Examine the following key steps you would take as an IT support technician to install a system board. Plan the installation. Carefully unpack the new system board and inspect it for any visible damage. Ensure that the system board is compatible with the CPU, RAM, power supply, and the computer case. This includes checking the form factor to make sure the motherboard fits in the chosen case. Consult the system board and case manuals for specific instructions, such as screw locations, mounting standoffs, and any proprietary installation methods. Determine whether other components, such as the CPU, CPU cooler, or RAM, should be installed before placing the system board in the case. Think about cable routing and how the various power and data cables will be organized when the system board is installed. An IT support technician unpacking a system board and looking at it with a magnifying glass. Prepare your workspace for installation. Before you begin, ensure you have the necessary tools and a static-free work environment. The tools you'll need include screwdrivers of different sizes, an anti-static wrist strap, wrenches, tweezers, and thermal paste. Position yourself in a clean and well-lit workspace. If your workspace is not well lit, you can use a task light, flashlight, or pen light to give you more light. Prepare your workspace. Having a well-prepared environment for installing a system board includes the following. Organizing components and tools, arrange the system board, processors, RAM, and other hardware. Include containers for screws and small parts to keep them accessible and organized. Implementing static protection, use an anti-static wristband and ground yourself. Keeping a manual or guide nearby, have reference material on hand for guidance. Maintaining cleanliness, keep the workspace clean and free from food or drinks. Planning waste disposal, have a method for handling packaging or old components. Remember to always work in a static-free environment, handle components with care, and consult the system board manual for any specific instructions. An IT support technician standing in front of a desktop tower that is sitting on a desk with a screwdriver and wrist strap. Prepare the case. If you haven't already, remove the side panel of the computer case. Most cases have screws at the back panel holding the side panel in place. Set the screws aside in the place you created for small parts. An IT support technician holding the side panel of a computer case that is sitting on a desk. Install the system board. Secure the standoffs to the case using screws. The standoffs prevent direct contact between the system board and the case. Carefully place the system board into the case, aligning it with the standoffs. Make sure the input/output, I/O, shield on the system board lines up with the corresponding holes in the case. Use the provided screws to secure the system board to the standoffs in the case. Be gentle and avoid over-tightening the screws. Double-check all connections to ensure everything is securely in place. An IT support technician installing a system board into a computer case that is sitting on a desk. It's installed. Now, you can finish installing the rest of the desktop components and configuring them. Choosing and installing RAM. RAM is a form of computer memory that the system can read or change in any order. The system typically uses it to store working data and machine code. The more RAM a computer has, the more data it can handle at once without having to access the slower hard drive or solid-state drive, SSD. This leads to faster load times for programs and files, allowing for smoother multitasking and overall improved system performance. As an IT support technician, you might need to install RAM modules into a system board. RAM modules, also called sticks, are small circuit boards that technicians install into dedicated slots on the system board. IT support technicians install RAM modules if a computer is running slow or struggling with running multiple applications. They might also install additional RAM modules in a data center's servers to handle more users or run complex databases more efficiently. Installing RAM isn't as complex as installing a CPU. However, it's important to choose RAM modules that are compatible with your system board and meet your technical needs. To choose appropriate RAM modules, determine the type of RAM that the system board supports, check the maximum capacity, and evaluate your usage needs. Once you have a RAM module that is compatible with your system board, you can begin installing the RAM. Review the following scenario to learn how an IT support technician installs RAM. Introduction. Talia, an IT support technician at Tier Corporation, received an email from a designer, Deva, who is struggling with his desktop computer. He uses heavy multimedia applications and 3D rendering software, which are running slowly. RAM is measured in gigabytes, GB. After assessing the situation, Talia found that Deva's computer only has 8 GB of RAM, which is insufficient for his work needs. She decides to upgrade the RAM to 32 GB. Step 1. Identify the right RAM. An IT support technician looking into the inside of a desktop computer at the RAM. First, Talia identifies the right type of RAM that's compatible with Deva's desktop. She checks the model of the system board and the manufacturer's website to determine the type of RAM the system board can support and its maximum supported speed and capacity. After researching, she decides to get 2 modules of 16 GB DDR4 RAM at 3200 MHz. Step 2. Purchase the RAM. An IT support technician purchasing RAM modules. Talia forwards her findings to the department head and requests approval for the purchase. Once she receives approval, she places an order for the RAM from a reputable computer hardware supplier. Step 3. Prepare for installation. A man sitting at a desk, working on his desktop computer. While waiting for the RAM to arrive, Talia asks Deva to back up his important files. Although installing RAM is usually safe, it's always good to take precautions. Step 4. Install the RAM. An IT support technician installing a RAM module into a system board. Once the RAM arrives, Talia heads to Deva's office and shuts down his computer. She unplugs the power cable and opens the case. She uses an anti-static wristband to prevent potential damage from static electricity. She locates the RAM slots on the system board. Talia carefully removes the old RAM modules by releasing the clips on the ends of the slots. Then, she aligns the new RAM modules with the slots, making sure the notches on the RAM and slots line up correctly. She presses down on the RAM until the clips snap into place. Step 5. Test the RAM. An IT support technician sitting at a desk in front of a computer that has a graph on it. After successfully installing the RAM, Talia closes the case, plugs in the power cable, and starts the computer. Once she has ensured that the BIOS recognizes the RAM, she saves the settings and continues booting the computer into the operating system. Once the operating system is loaded, Talia checks the system properties to confirm that the full amount of RAM is showing up. Finally, she runs a memory diagnostic tool to ensure the new RAM is functioning correctly and without errors. Step 6. Follow-up. A man sitting at a desk in front of a computer, talking to another person standing beside the desk. Talia informs Deva that the RAM upgrade is complete. She asks him to use the computer as normal and report back if he encounters any issues or if his applications are still running slowly. After a few days, Deva reports that his design software is running much smoother and faster, confirming that the RAM upgrade was successful. Summary. That's the overall process for installing RAM. By choosing and installing additional RAM in Deva's desktop, Talia helped him improve his productivity. It's important to note that RAM is volatile memory, meaning it only retains data if the computer is on. Once the computer is off, all data in RAM is lost. This is why desktop computers have non-volatile storage like ROM, a hard drive, or SSD to permanently store files and applications. Next, you'll explore choosing a storage solution. Permanent storage solutions, such as hard disk drives, HDDs, and solid-state drives, SSDs, are indispensable to desktop computers. They retain long-term data, including operating systems, applications, and user files. They deliver higher capacities than RAM, ranging from hundreds of gigabytes to multiple terabytes, which is crucial for storing large volumes of data. While permanent storage access speeds are slower RAM, they are crucial for maintaining data even when you turn off the computer. Aspects of a storage solution. A storage solution for a desktop computer typically has several requirements and aspects for technicians to consider. Select each section to learn more about different aspects of storage solutions. Type of storage. Hard disk drives are a traditional storage method that uses magnetic storage to read and write data. Solid-state drives have no moving parts. There are two main types of SSDs, Serial Advanced Technology Attachment, SATA, and Non-Volatile Memory Express, NVMe, technology. SATA is a standard connection method used to transfer data between the computer's motherboard and storage devices like hard drives and SSDs. NVMe is a protocol designed specifically for connecting SSDs to a computer's motherboard, offering faster data transfer speeds compared to SATA. There are two common versions, NVMe Gen 3 and NVMe Gen 4. There are also hybrid solutions. Some desktops use a combination of HDDs and SSDs. Hybrid solutions typically store the OS on the SSD and store applications and data on the HDDs. This provides the best of both worlds: fast boot times from the SSD and ample storage space from the HDD. Capacity. Capacity is the total amount of data that the storage solution can hold. This can range from a few gigabytes, GB, to several terabytes, TB, or more. The right capacity depends on the user's needs. For instance, a gamer or a video editor will need more storage compared to a user who uses their computer only for web browsing and office applications. Speed. Speed is how quickly the storage solution can read and write data. SSDs are much faster than HDDs, which can lead to shorter boot times, quicker file transfers, and smoother performance in applications that need to read or write a lot of data. The speed and performance of SSDs can also vary based on the technology they use. In general, as you move from SATA to NVMe Gen 3 and then to NVMe Gen 4, there will be an increase in speed. Reliability. Reliability refers to the expected lifespan and stability of the storage solution. SSDs are more reliable than HDDs because they have no moving parts, making them less likely to suffer mechanical failure. Form factor. Form factor is the physical size and shape of the storage device. Most desktops use 3.5-inch HDDs or 2.5-inch SSDs, although M.2 SSDs, which are even smaller, are also becoming more common. Interface. The interface is how the storage device connects to the rest of the computer. The most common interfaces are SATA, for HDDs and some SSDs, and PCIe, for NVMe SSDs. Expandability and upgradability. Desktop computers often have multiple slots for adding extra hard drives to expand or upgrade storage capacity if needed. Data security. Encryption is a form of data security. Some storage devices come with built-in encryption, which can help protect data if someone steals the device. Software and firmware. The characteristics of the software and firmware that manage a storage device contribute to how efficiently and dependably the device can handle the tasks it's designed to perform. Overly large or complex pieces of software might consume unnecessary resources. The specific tasks and functions that the software and firmware perform directly influence how the storage device operates. Cost. The cost of the storage solution is always an important consideration. The price of higher capacity and faster performing devices is typically more than for lower capacity and performance. The best storage solution for a desktop computer depends on the individual user's requirements, such as the need for speed, capacity, reliability, and cost. Activity: choose the best storage solution. In this activity, you're an IT support technician at Gediatech, a cutting-edge pharmaceutical research company. Samantha, a talented data analyst, has just joined the team and will be working on some of the company's most prestigious projects. You are responsible for upgrading Samantha's desktop storage from what is available with the company's standard setup. Samantha's work involves handling large data sets, complex data analysis tools, 3D rendering of genetic sequences, and other resource-intensive tasks. Her manager provided you with the following specific storage needs that are crucial for Samantha's workflow. High speed: Samantha needs blazing fast access to large data sets to keep up with her demanding projects. Large storage capacity: with multiple ongoing projects, she needs enough space to store various report files and large data sets. Reliability: the storage solution must be robust and reliable because any data loss would be catastrophic for her deadlines. Expandability: future expansion capabilities should be available as Samantha's research projects grow. Data security: Samantha needs adequate security measures to protect sensitive patient and company data. You've shortlisted 3 storage solutions based on the budget and Samantha's needs. Review the specifications for each storage solution and choose the solution that you think will best fit Samantha's needs. It's okay if you don't know everything included in the following solutions just yet. Simply review and familiarize yourself with the product and specifications terminology. Here is the extracted text from the table, converted into complete sentences organized by solution. Solution 1. Type of storage: this option utilizes a hybrid solution consisting of a 4 TB 3.5-inch HDD running at 7200 RPM and a 2 TB NVMe M.2 SSD. Storage capacity: the total storage capacity for this configuration is 6 TB. Speed: the HDD features a read and write speed of 200 MB/s, while the NVMe SSD delivers a 5000 MB/s read speed and 4500 MB/s write speed. Reliability: the SSD is rated for an MTBF, mean time between failures, of 2,500,000 hours. Form factor: it accommodates a 3.5-inch HDD and an M.2 2280 NVMe SSD. Interface: the system uses SATA 3 and PCIe Gen 4 X4 interfaces. Expandability and upgradability, it offers 2 additional M.2 slots for future upgrades. Data security, it provides AES 256-bit hardware encryption on the SSD. Software and firmware, it includes the Creative Pro monitoring suite. Solution 2. Type of storage, this option utilizes a hybrid solution consisting of a 1TB 3.5-inch HDD running at 5400 RPM and a 256 GB SATA 3 2.5-inch SSD. Storage capacity, the total storage capacity for this configuration is 1.25 TB. Speed, the HDD features a read and write speed of 100 MB/s, while the SATA SSD delivers a 5500 MB/s read speed and 520 MB/s write speed. Reliability, the HDD is rated for an MTBF of 800,000 hours. Form factor, it accommodates a 3.5-inch HDD and a 2.5-inch SATA SSD. Interface, the system relies entirely on the SATA 3 interface. Expandability and upgradability, it offers 2 additional 3.5-inch HDD bays for future expansion. Data security, it utilizes standard software encryption. Software and firmware, it includes the basic health monitoring suite. Solution 3. Type of storage, this configuration exclusively uses an enterprise-grade 512 GB NVMe M.2 SSD. Storage capacity, the total storage capacity is 512 GB. Speed, the NVMe SSD delivers a read speed of 3500 MB/s and a write speed of 3200 MB/s. Reliability, the SSD is rated for an MTBF of 3 million hours. Form factor, it uses an M.2 2280 form factor. Interface, the system utilizes a PCIe Gen 4 X4 interface. Expandability and upgradability, it offers 4 additional M.2 slots for expansion. Data security, it provides AES 256-bit hardware encryption along with RAID support. Software and firmware, it includes the Server Max monitoring suite with predictive failure analysis. Evaluate your thinking. Does your answer account for the following? Solution 1 aligns well with Samantha's needs for speed, capacity, and security. The data security is also robust with hardware encryption, which is necessary for Samantha's work. Plus, the option to expand with 2 more slots adds flexibility for future needs. The reliability is good, but not the highest among the options. Solution 2 might struggle to meet Samantha's needs. Although it's more budget-friendly, its speed and storage capacity are limited, and this could hinder Samantha's complex data projects. This solution is able to be expanded, but the data security and reliability might not match what's required. Solution 3 emphasizes speed and reliability, which are 2 of Samantha's primary needs. This solution also provides ample security for Samantha's data. However, the storage capacity is significantly limited at 512 GB. This lack of storage might not support Samantha's need to handle large data sets, making this option less ideal despite its other impressive features. Based on the requirements provided for Samantha's work, Samantha needs a hybrid solution that has high speeds, so Solution 1 would be the best fit. Now that you've explored the different aspects of choosing a storage solution, let's learn about how to install and configure peripherals, such as mice and keyboards. Installing and configuring peripherals. Peripherals are external devices that connect to a computer to provide additional functionality and enhance the user experience. They play an essential role in transforming a computer's raw capabilities into a complete and efficient system tailored to the user's specific needs. The components you have learned about so far, such as the system board, CPU, and storage devices, are necessary for the basic operation of the computer. These components are responsible for essential tasks such as connecting components, system board, processing instructions, CPU, and storing data, storage devices. On the other hand, peripherals add specific functionality or features, such as allowing the user to input data through a keyboard or mouse, outputting information via a monitor or printer, or adding extra storage or networking capabilities. The ability to install peripherals is a vital skill for IT support technicians because it allows them to ensure users can fully utilize their desktops, customize systems to meet individual requirements, and troubleshoot issues when peripherals cause conflicts with existing hardware and software. Installing and configuring peripherals on a desktop computer is a well-defined process. Following best practices and maintaining attention to detail are key aspects of this task for an IT support technician. Introduction. An IT support technician installing a printer on a desktop computer. Imagine that you are setting up a desktop for the first time for a new employee at your company. You need to install a mouse, keyboard, and printer. Step 1. Identify the peripherals. The first step is to identify the peripherals you'll be installing. In this case, you're installing a mouse, keyboard, and printer. Ensure that the mouse, keyboard, and printer are compatible with the computer's operating system and hardware. Note, you might need to install other devices, such as scanners, webcams, external drives, and other USB devices, in the future. Step 2. Prepare the desktop computer. Power off the system. Before connecting any peripherals, it's best to power off the computer to avoid any potential electrical issues. Inspect ports and cables. Check the available ports on the computer, and ensure you have the correct cables for connecting the peripherals. Step 3. Install the peripherals. Complete the physical connection. Connect the mouse, keyboard, and printer to the appropriate ports on the desktop computer using the correct cables. These peripherals typically connect using USB ports. Some peripherals, such as monitors, use HDMI, VGA, or Ethernet ports. An HDMI port allows high-definition audio and video signals to be transmitted between a computer and a monitor or TV. A video graphics array, VGA, port is an analog video interface used for connecting a computer and monitor or projector. An Ethernet port enables a wired network connection for data communication between a computer and networking devices. Power on the system. Turn on the computer and allow the operating system to recognize the newly connected mouse, keyboard, and printer. Install the drivers. Most modern operating systems will automatically detect and install the necessary drivers. If not, you might need to install them manually. Drivers are typically available on the manufacturer's website or included on a CD with the device. Step 4. Configure the peripherals. Configure the settings. Once the system has installed the drivers, go to the operating system settings or control panel to configure the peripherals. You might need to set the default printer or configure settings for the keyboard. Install software. Some peripherals, like the printer, might require specific software to unlock additional features. If provided by the manufacturer, follow the installation instructions. Step 5. Test the peripherals. Perform a functionality check. Test the newly installed mouse, keyboard, and printer to ensure they are working correctly. Use the mouse to navigate to a document, make some edits using the keyboard, and print a test page from the printer. Troubleshoot. If you detect any issues, consult the user manual, manufacturer's website, or relevant online forums. Common issues might involve driver conflicts, incorrect settings, or physical connection problems. Step 6. Document the installation. Keep records. Maintain a record of the installation, including the peripheral model, serial number, installation date, and any specific configurations. This can be helpful for future troubleshooting or audits. Summary. You successfully followed the process for installing peripherals on a desktop for an employee. In the future, when you need to install a new device or a different peripheral like a webcam, you can follow these same steps. The installation steps might vary slightly depending on the peripheral you're installing, but these general steps will apply to most scenarios. Summary and looking ahead. In this lesson, you learned how to install and configure a CPU, install a system board, choose and install RAM, and which tools to use for each task. You also learned to choose storage drives as well as the process for installing and configuring different types of peripherals. In the next lesson, you will learn how to identify and troubleshoot desktop computer hardware issues. About this lesson, troubleshooting desktops. In this lesson, you'll learn how to troubleshoot hardware issues and apply preventive maintenance tasks on desktop computers. You'll discover common symptoms and causes of hardware issues, the purpose of log files in troubleshooting, and the value of regular maintenance tasks to prevent future issues for desktops. You'll also learn about keeping drivers and firmware up to date. A technician using tools on parts of a desktop computer. In IT support, troubleshooting hardware issues and applying preventative maintenance tasks are essential for ensuring system reliability and performance. The troubleshooting process typically includes the following. It begins by identifying the problem, followed by basic checks, such as inspecting connections and restarting the system. Then, technicians diagnose specific components such as the power supply, memory, hard drive, graphics card, motherboard, and CPU to help to isolate the issue. And technicians use diagnostic tools and consult online resources and documentation to aid in a deeper analysis. Preventative maintenance, on the other hand, includes the following. Keeping systems updated. Cleaning regularly. Monitoring system performance. Implementing backup strategies. Educating users. Investing in quality hardware. Maintaining proper documentation. Together, these practices can reduce future problems and maximize system longevity. Scenario: troubleshooting and preventative maintenance at work. Take a moment to review this short scenario to learn how troubleshooting and preventative maintenance go together. Antonio is a newly appointed IT support technician at a biotech startup. He received a complaint from an employee about a computer that was crashing frequently. Antonio begins the troubleshooting process by visiting the employee at her desk. He asks her questions to understand the issue and then inspects the system himself and tries to replicate the problem. Based on what he learned from the employee and what he observes when replicating the problem, Antonio thinks it might be a memory issue, so he runs the Windows Memory Diagnostic tool to help him diagnose the problem. The tool confirms his suspicion that her desktop memory is faulty, so he orders a replacement memory module and schedules a time to replace it. Male IT technician working at a computer, explaining steps to a female colleague at a desktop. In addition to troubleshooting and fixing the immediate memory problem, Antonio also notices that the desktop tower has some dust on the fan and on the vents on the back of the computer that provides air intake. He takes the opportunity to apply preventative maintenance by carefully cleaning the fan, the air intake slots, and the internals with a small vacuum and some compressed air. Antonio also educates the employee about the importance of keeping the system clean and following best practices, such as regularly clearing cache, to avoid future problems with her computer's memory. The preventative measures ensure that the computer doesn't store unnecessary data in short-term memory, freeing the RAM up to store the data the employee is actually using. Evaluate your thinking. Does your answer account for the following? Antonio's systematic approach to troubleshooting, combined with his application of preventative measures, not only resolved the immediate issue but also helped enhance overall system performance. His actions exemplified the blend of reactive problem-solving and proactive care that defines the role of an IT support technician. Now that you've explored how troubleshooting and preventative maintenance go together, let's learn how to identify common desktop hardware issues. Identify common hardware issues and their causes. Although desktop computers can be simple to use, they are complex machines with many interdependent parts. That can make it difficult to determine the source of a specific problem occurring on a desktop computer. Many times, the symptom can appear to be related to a particular cause, but the true cause is something that might, on initial analysis, appear to be unrelated. Here's an example to illustrate this for you. A user's monitor on a desktop computer appears to not be getting power. The symptom is that the monitor is dark, so the user cannot operate the computer. As an IT support technician for the case, you visit the user to check the cables, ensure that power is getting to the monitor, and run a power diagnostic, which results in no issues. Regardless of what you try, the monitor remains dark. You soon determine the true cause of the problem. The user accidentally reduced the brightness of the monitor, so the monitor appears to be malfunctioning. The issue was not that the monitor was malfunctioning or that it wasn't receiving power. The monitor is doing exactly what it was told to do by the user, causing the dark monitor symptom. A situation like this can make troubleshooting a frustrating task. But, by evaluating the appropriate components and understanding common symptoms, you can identify and resolve hardware issues. Let's explore this in more depth. Select each section to learn more about areas to investigate and causes of common symptoms. Conduct a visual inspection. Loose connections, loose or damaged cables can cause numerous problems. Always start with a visual inspection of all connections, including power, USB, and video cables. Wear or damage, look for visible signs of wear, burn marks, or other physical damage that might indicate a hardware failure. Check for power issues. No power, if the computer doesn't turn on, check the power cables, PSU, and the power source, such as a wall outlet. Unexpected shutdowns. Unexpected shutdowns might be related to a faulty PSU, overheating, or problems with other components like the motherboard. Check for memory issues. System crashes and blue screens. Memory errors might lead to frequent crashes. Tools such as Windows Memory Diagnostic can help determine whether RAM is the culprit. Poor performance. Insufficient or failing memory can lead to sluggish system performance. Modern desktops use the hard disk to compensate for insufficient RAM, but applications that run slowly can indicate the system needs more RAM. Check for storage issues. Failure to boot. A failure to boot might signal a problem with the hard drive or SSD. Running a Windows command line tool such as chkdsk can help diagnose the issue. Clicking or grinding noises. Such noises from the hard drive are often signs of a mechanical failure. Check for graphics issues. Display artifacts and glitches. Display issues might indicate a problem with the graphics card. Try updating drivers, resetting the card, or testing it in another system. Monitor issues. If the display is blank or distorted, check the monitor connections and settings. Check for cooling and overheating issues. System overheats and shuts down. System shutdowns can be caused by overheating. Determine if the fans and cooling systems are working. Accumulated dust or a failed cooling component can also cause overheating. Loud fan noises. Such noises might be a sign of blocked airflow or a failing fan. A computer that is running at full capacity might keep the fan at full speed, which can cause loud fan noises. Consult documentation and seek expert advice. Manufacturer's manuals. Manuals often contain troubleshooting guides specific to the hardware. Online forums and resources. Communities of professionals often share insights and solutions for common issues. Consult with senior colleagues. Don't hesitate to consult more experienced IT support technicians for advice and help. After identifying and resolving any immediate physical or visual issues with a desktop computer, such as cooling or overheating, an IT support technician might still need to dig deeper to uncover more elusive problems. Even when a system seems to be running without any apparent hitches, underlying hardware issues might cause subtle degradation in performance or unexpected behavior. Here's where diagnostic checks come into play. They offer insights beyond what the eye can see. Let's explore how checking logs for hardware errors can assist in pinpointing those hidden hardware issues that might not be readily apparent to the user. Check logs for hardware errors. When software has issues, users generally know about it because the software crashes or stops working and shuts down due to a bug or series of bugs. Hardware issues. many times, aren't as obvious. Users might experience the performance of their computer slowly degrade, or they might be unable to open a file they saved to their storage device. The source of these issues might not be clear. One way to determine if hardware is the cause of issues is to run diagnostic checks that produce log files. Log files are computer-generated files that contain a record of everything that happens within a system, including information about operations, activities, and usage patterns. They can tell technicians if the hardware they're scanning is running properly. Many operating systems come with basic diagnostic software that IT support technicians can use to diagnose hardware. There are also many third-party tools that offer more features and capabilities. Review log files. Log files produced by diagnostic tools can contain a lot of information that can be difficult to decipher. Thankfully, most log files include keywords that can be used to determine whether the hardware is operating properly. Examine the following example entries from two log files from a diagnostic tool that analyzed two different SSD storage devices. Entries from a log file for an SSD with no errors. On July 20, 2023, a system startup event occurred, during which the SSD initialized successfully. On July 20, 2023, a write operation event occurred, which involved writing data to SSD. Entries from a log file for an SSD with errors. On July 20, 2023, an event log categorized as an error occurred because the system failed to write data to the SSD. The specific error code associated with this event is 0xC00F0035. The system generated the following error message: data corruption detected during write operation. What can you conclude from the log files? Notice that in the first entry, the log shows that the SSD was able to write data to the disk successfully. Notice that in the second entry, the SSD was unable to write the data, and the information in the log file shows the disk clearly has an error indicated by the keywords, error and data corruption. Tip: in most cases, you don't need to know what the specific error code means because manufacturers use the codes to dig deeper into recurring issues. Once you've determined that the hardware has an issue, you can determine the next steps. Generally, when an HDD or SSD has data corruption, as in the earlier example, it's time to back up whatever data you can and replace the storage device. This can save you hours of work trying to troubleshoot the symptoms of corrupted files or a slow desktop computer. Use log files for quick insights. You can use diagnostic tools and the log files they produce in this way to get quick insights into what otherwise might be obscure issues. You can run diagnostics on all kinds of desktop hardware, including monitors, network hardware, storage and RAM, and even peripherals like printers. If the logs are unclear, you can post files to user groups on the internet or send log files to other IT support technicians to help you determine whether your hardware has problems or not. Ruling out or confirming substantial hardware problems using logs can help you focus on the right things. It can also save you time by confirming that you can only resolve an issue by actually replacing the hardware. Perform regular maintenance tasks to prevent hardware issues. IT support technicians have the responsibility of ensuring optimal performance and the longevity of desktop hardware. Regular maintenance not only minimizes the risk of unexpected failures but also enhances overall system efficiency. Performing common maintenance tasks on desktop hardware requires attention to both hardware and software. Taking a structured approach will help ensure that you cover all the essential areas. Regularly practicing these tasks and adapting to the unique needs of each system will build your confidence and expertise in maintaining desktop computers efficiently and effectively. Review the tables to learn ways IT support technicians keep desktop hardware systems running at their best. Each section includes symptoms that indicate when a technician should perform maintenance. Physical components. If overheating occurs during operation, fans operate noisily, or dust accumulates inside the case, the required maintenance is to clean and inspect by looking for dust, debris, or physical damage and cleaning it. If connectivity is intermittent, cables show visual fraying or bending, or connections are loose, you must examine cables to ensure that all connections are secure and there is no visible damage to the cables. Operating system and software. Update the operating system and software. If security vulnerabilities are present, incompatibility with new hardware is noticed, or performance degrades over time, you should update the operating system and software. Keep all operating systems, drivers, and software up to date to ensure security and compatibility. Scan for malware. If unexpected pop-ups or ads appear, the system becomes unstable, or unusual network activity is detected, you must scan for malware. Regularly run anti-malware scans to detect and eliminate any malicious software. Cooling and power systems. If overheating occurs during normal operation, fans run at high speed, or dust accumulates on cooling components, you should inspect the fans and cooling systems to verify that all cooling components are working properly and are free from obstructions. If unexpected system shutdowns happen after heavy use, power lights flicker or become unstable, or a burning smell or sparks are noticed, you should examine the power supply and look for any signs of failure or irregularities in the power supply unit, including unexpected shutdowns or burning smells. Regular backups. Backup important data. When critical data is lost, difficulty in data recovery after failure is experienced, or frequent changes to essential files occur, you should regularly save copies of essential data to prevent loss in case of hardware failure. Test backups. If you experience an inability to restore from a backup, errors occur during the backup process, or you detect stale or outdated backup data, you must periodically ensure that backups are functioning correctly and that data can be restored from them. Documentation. Symptoms and required maintenance. Inconsistency in maintenance performance tasks. There is an inconsistency in the performance of maintenance tasks. Difficulty in tracking historical issues occurs. Difficulties occur when trying to track historical maintenance issues. Confusion arises when multiple people work on the same task. Confusion frequently arises whenever multiple people work on the exact same task. Maintenance required. Keep records. The required maintenance action is to keep records. You should keep comprehensive records of all maintenance tasks, including dates, specific details, and any issues that arise. This is a lot of information to absorb. Here's a resource you can save for future reference. The importance of keeping hardware drivers and firmware up to date. Neglecting updates to drivers and firmware can lead to performance issues, unexpected conflicts, and even complete failure of essential hardware components. What might seem like inconsequential notifications can, in fact, be crucial to maintaining the optimal functioning and security of a system. A desktop computer showing the screen with diagnostic software running. Regular maintenance includes updating drivers and firmware. This isn't just a technical recommendation but rather an essential practice for anyone relying on computer technology, whether for professional work or personal use. It ensures that the system stays compatible with the latest software, operates at peak performance, remains secure against potential vulnerabilities. Scenario: a close call. In the rapidly evolving world of technology, staying up to date with software and hardware updates is not just a matter of convenience but a critical component to ensuring system functionality and security. The following scenario with Katharina, a freelance graphic designer, illustrates the importance of paying attention to updates and the potentially disastrous consequences of neglecting them, even for experienced users. Her story serves as a cautionary tale and a valuable lesson for anyone who relies on technology in their daily work. Consider Katharina's situation. She's working on a major project for a new client. She prides herself on her top-of-the-line desktop computer that she built herself, filled with specialized tools and software. Woman sitting at a table and writing at home office. Recently, she has been noticing a slowdown in her system, and her innovative graphic tablet seems to stutter occasionally. She remembers seeing notifications about updates for some drivers but ignored them, thinking they weren't important. Her project deadline is looming, so she thinks she doesn't have time to deal with updates. But today, while making the final changes to her design, her system crashes. Panic sets in as she attempts to reboot her devices, only to discover that her graphic tablet is no longer functioning properly and the specialized design software is behaving erratically. The error messages point to a driver conflict. Katharina frantically calls her tech-savvy friend. She learns that a recent update to her design software requires the latest drivers for her graphic tablet, something she has neglected to install. To make matters worse, there is also a critical firmware update for her SSD that she overlooked, leading to the slowdown of her system. Katharina's friend helps her update the necessary drivers and firmware, but she loses precious time. Katharina barely makes the deadline and realizes now just how close she came to a complete disaster. What do you think? Employability skills. Critical thinking. What additional preventative maintenance techniques could Katharina have practiced to improve the performance and reliability of her system, and what symptoms would they have addressed? Evaluate your thinking. Does your answer account for the following? Updating other drivers. Regularly updating the operating system, drivers, and software can help Katharina avoid incompatibility and performance degradation. Scheduling backups. Scheduling regular backups and testing them can ensure Katharina doesn't lose critical data for her projects. Managing storage and memory. This includes regular checks for hard drive health, disk space, and memory usage, which can help ensure she has the space and memory to complete her work. Updating drivers and firmware. It's important to properly and methodically update drivers and firmware. Review the lists below to get familiar with proven techniques that IT support technicians use to keep drivers and firmware up to date so that they can keep desktop computers running efficiently and securely. Drivers. Windows Update. For Windows users, Windows provides updates for drivers through its Windows Update service. Regularly checking for updates ensures that drivers are current. Manufacturer's software. Windows, Mac, Linux. Many computer manufacturers provide software that will check for and update drivers specifically tailored to individual hardware. Manual download from the manufacturer's website. Windows, Mac, Linux. If you know the specific hardware components, you can go directly to the manufacturer's website and download the latest drivers. This might include GPU, sound, network, or chipset drivers. Using third-party software. Windows, Linux. There are many third-party tools designed to scan a system for outdated drivers and automatically download and install updates. Device Manager. Windows. You can manually update drivers through the Device Manager by right-clicking a device and choosing to update the driver. Linux-specific drivers. Package Manager. Most modern Linux distributions use a package manager such as apt for Debian/Ubuntu or yum/dnf for Red Hat/Fedora. Technicians can use these to update drivers. For example, you might run sudo apt update and sudo apt upgrade using the command line interface on Ubuntu to update all packages, including drivers. Distribution-specific tools. Some distributions of Linux operating systems offer specific tools to manage updates, such as Ubuntu Software Updater, which technicians can use to update drivers along with other packages. Kernel updates. Often, driver updates in Linux come with kernel updates. If you keep a user's kernel up to date, you'll keep their drivers up to date as well. Graphics drivers. Graphics drivers might have specific tools or processes, such as using the additional drivers tool in Ubuntu for NVIDIA or AMD drivers. Manual compilation. In some rare cases, you might need to compile and install a driver manually from the source code. This is usually only necessary for uncommon or very new hardware. Follow community guidelines. Linux has a vibrant community, and many forums and wikis provide distribution-specific instructions for keeping drivers up to date. Firmware. BIOS/UEFI updates from the manufacturer's website. If you need to update the BIOS or UEFI for a user, you'll generally find these updates on the system board's manufacturer's website. Follow the specific instructions exactly because improper updates can cause serious issues. Using the manufacturer's update tools. Some manufacturers include tools in their pre-installed software packages that can check for and install firmware updates automatically. Operating system updates. Occasionally, standard operating system updates deliver firmware updates, such as Windows Update. Check peripheral websites. If a user has peripherals such as printers or scanners, make sure to check their respective websites for firmware updates. This is a lot of information to absorb. Here's a resource you can save for future reference. Best practices for updating drivers and firmware. IT support technicians know that keeping drivers and firmware up to date is a key part of maintaining a healthy computer system. When update notifications pop up, they might seem unimportant to users, but ignoring them can lead to problems such as software conflicts, security vulnerabilities, and poor performance. But it's not just about accepting every update. Using best practices is crucial when updating drivers and firmware. Following best practices ensures that technicians perform updates in a controlled and consistent manner. Reduce the risks of compatibility issues, system crashes, or other unexpected problems. It's about knowing when and how to update, choosing the right versions, and getting users on a regular update schedule. Regularly updating drivers and firmware according to these best practices is more than just a good idea, it's necessary for making sure computers work well and stay optimized. Backup before updating. Always back up essential data before performing updates, especially firmware updates. A failed firmware update might render the system unbootable. Don't fix what's not broken. If a device is working well and there's no critical security update, you might not need to update the driver. Sometimes, newer drivers might introduce compatibility issues. Read release notes. Always read the release notes for driver and firmware updates. They often contain essential information about what has changed and any known issues. Avoid unofficial sources. Only download drivers and firmware from reputable sources, such as the manufacturer's website or official tools, to avoid malware or compatibility issues. Schedule regular checks. Set a schedule to regularly check for updates, either manually or through automated tools, to ensure users are always running the latest and most secure versions. These techniques can help you ensure that the desktop computers you're maintaining are secure, running at their peak performance, and meeting the needs of your users. Summary and looking ahead. In this lesson, you learned about troubleshooting hardware issues and the importance of preventative maintenance. You learned to identify common hardware issues and their causes, and how to check log files for hardware errors. You also explored regular maintenance tasks to prevent hardware issues and some symptoms to help you identify which maintenance is required. Finally, you learned about the importance of keeping hardware drivers and firmware up to date and some best practices. You've completed the final lesson of this module. Next, you'll review the module's key points and explore additional resources related to desktop computer hardware and troubleshooting. Key concepts. 1. Desktop hardware is the collection of physical components that make up a desktop computer, including the system board, CPU, RAM, ROM, storage, and peripherals. 2. The system board is the main circuit board that connects and communicates with all the other components in the computer. It contains the chipset, which stores the BIOS settings and powers the real-time clock. 3. The CPU is the main processor of the computer that executes instructions and performs calculations. The CPU operates on a binary system of zeros and ones and requires a compatible socket, thermal paste, and a cooler to function properly. 4. RAM is a form of temporary memory that holds data that the CPU needs to access quickly. RAM comes in modules that can be installed into memory slots on the system board. The type, speed, and capacity of RAM can affect the performance of the computer. 5. ROM contains vital data for the computer's operation. It remains intact even when a user turns off the computer. 6. Storage drives are devices that store data for long-term use. They can be either hard disk drives, HDDs, or solid-state drives, SSDs, which have different characteristics in terms of speed and efficiency. 7. Peripherals can enhance the functionality and usability of a computer. They are external devices that connect to the computer via input/output ports, cables, or wirelessly. They include keyboards, mice, printers, monitors, and scanners. 8. Installing and configuring a CPU includes the following steps. Prepare the system board. Check the CPU socket. Lift the CPU socket retention arm. Align the CPU and socket. Install the CPU. Apply thermal paste. Install the CPU cooler. 9. Installing a system board involves planning the installation, preparing the workspace for installation, preparing the case, and installing the system board. 10. To choose the correct RAM modules, determine the type of RAM that the system board supports, check the maximum capacity, and evaluate usage needs. 11. There are many aspects to consider when choosing a storage solution. These include type of storage, capacity, speed, reliability, form factor, interface, expandability and upgradability, data security, software and firmware, cost. 12. Troubleshooting desktop hardware issues involves identifying the problem, inspecting connections, restarting the system, and then diagnosing specific components to isolate the issue. 13. Preventative maintenance includes keeping systems updated, cleaning regularly, monitoring system performance, and implementing backup strategies. 14. Identifying hardware issues can include conducting a visual inspection, checking for power issues, checking for memory issues, checking for storage issues, checking for graphics issues, checking for cooling and overheating issues, consulting documentation and expert advice. 15. Log files are computer-generated files that contain a record of everything that happens within a system, including information about operations, activities, and usage patterns. 16. Regular preventative maintenance not only minimizes the risk of unexpected failures but also enhances overall system efficiency. 17. Regularly updating drivers and firmware ensures that the system stays compatible, operates at peak performance, and remains secure against potential vulnerabilities. Big ideas. In addition, you explored or practiced these skills. You identified the main components of a desktop computer and their functions, such as the system board, CPU, RAM, and storage drives. You determined the function of the CPU in processing information using binary digits and how it affects the performance of a desktop computer. You examined the characteristics of RAM and its role in providing temporary storage for data that the CPU needs to access quickly. You examined the advantages of using solid-state drives, SSDs, and hard disk drives, HDDs, for long-term storage. You chose a storage solution based on user needs. You identified the role of power supplies, cooling systems, and cables in a desktop computer and how they can impact the system's stability and functionality. You reflected on how desktop hardware parts like the CPU, long-term storage, RAM, and system board change the way you think about desktop computers and how this knowledge might help you in daily life or future jobs. You chose the appropriate hardware maintenance task to address an issue based on symptoms. Employability skills. Analytical thinking. Identifying the main components of a desktop computer and their functions, such as the system board, CPU, RAM, and storage drives. Understanding how the CPU uses binary digits to process information. Identifying the advantages of using solid-state drives, SSDs, over hard disk drives, HDDs, for long-term storage. Creative thinking. Choosing the best storage solution for different scenarios based on factors such as speed and energy efficiency. Growth mindset. Consider how knowledge of desktop hardware parts can be applied in daily life and future career opportunities. Critical thinking. Describe how desktop troubleshooting and preventative maintenance contribute to long-term system reliability. Identify which preventative maintenance techniques were used and the symptoms they addressed. Choosing the appropriate hardware maintenance task to address an issue based on symptoms. Learning objectives. Now that you've completed this module, you should be able to identify the function and select the location of the main components of a desktop computer. Explain the processes to install a system board, central processing unit, CPU, random access memory, RAM, and peripheral for a desktop computer. Choose a desktop storage solution based on user needs. Determine a desktop hardware component to review and perform a maintenance task based on symptoms. Explore more resources. To explore concepts covered in this module in more depth, check out these resources. What does the inside of your PC look like? Opens in a new tab. This blog by Tim Fisher for LifeWire provides a tour of the hardware in a traditional desktop along with photographs. Check out more how-to guides from LifeWire, such as what is an expansion slot, opens in a new tab, and how to open a desktop computer case, opens in a new tab. Computer Basics, Inside a Computer, opens in a new tab. This online tutorial by gcfglobal.org can help build your understanding of what goes on inside a computer. Check out other tutorials on this website as well. Troubleshooting hard drive, HDD, issues, opens in a new tab. This IBM support web page provides an example of an online guide that IT support technicians might consult when troubleshooting.